So you're welcome. So we're going to be looking at this question on integration by parts. Now the question says that we should integrate x squared times the logarithm of x to base e with respect to x. Now if we look at this question, this is the integral of a function. X squared itself is a function and the log itself is a function. So when we are integrating the product of two functions, we have to use a method of integration that is called integration by parts. And the integration by part formula is shortly given as the integral of u, the v, is equal to uv minus the integral of v, the u. So this is a simple process that we have to follow. Now the question is, what is our u and what is our dv? So out of this integrand, we are going to be picking out our u and our dv. So the process is given as our u from the function has to be either the first function x squared or the second function the logarithm of x to base e. So we have to choose which of the function should represent our u and which of the function should represent our v. And a simple process is to understand which function is easily integrable and which function is easily differentiable. So in this case now, it is easy to differentiate the log function than to integrate the log function. So we can say let u be given as the log of x to base e. Then our dv from the left hand side, our dv is equal to the other function which is given as x raised to the power of 2. So at this instance, what do? We are going to differentiate this and integrate this. So from this, if we differentiate u with respect to x, we are going to be having this to be given as 1 all over x. So from our standard differentiation, when we integrate a log function, it gives us the reciprocal of that particular function. So this is what we are having. Then when we integrate this now, so take note that in u we are differentiating, in dv we are integrating so that we can get for v. So when we integrate this, we are going to be having this to be given as v is equal to the integral of x raised to the power of 2 with respect to x, and that is going to give us x squared integrated. Applying the rules of integration, we increase the power of this by 1, that is going to give us 2 plus 1, that is going to give us 3, divided by the new power, which is going to give us 3. So this is what we have now. So we can now carry out our substitution into this given formula for integration by parts. So this gives us the integral of u dv is actually given by this function, that is x raised to the power of 2 times the logarithm of x to base e with respect to x, and this is equal to our u is given by log x to base e, log x to base e. Then our v is given by x cubed over 3 minus the integral of v du. The integral of our v is x cubed over 3 times our du. The derivative of our u is given as 1 over x. That's going to give us 1 all over x with respect to x. So this is what we have now. So in this case, we can go on to say that this is going to be equal to this time this is written as x cubed over 3 times the logarithm of x to base e minus. Please take note that we have 3 at the denominator. It is a constant and a fraction, so we can factor it out of the integrand. So we have that to be 1 over 3 of the integral of x at the denominator. We'll cancel one of the x at the numerator so that we're left with x to the power of 2. So this gives us x squared dx. So from this now, we can finalize our work. Let me wipe this. We can finalize our work that this is going to be equal to x cubed over 3 times the logarithm of x to base e minus 1 over 3 times the the integral of x squared with respect to x is given as x raised to the power of 3. We increase the power of this by 1, so 2 plus 1 is going to give us 3. Then divide by the new power, which is that, so plus the constant of integration, since this is an indefinite integral, so that we have our result to be given as x raised to the power of 3 over 3 times the logarithm of x to base e, then 1 times this is multiplying this, so 1 times x cubed, that is going to give us minus x cubed over 3 times 3, that is going to give us 9, plus the constant of integration. So this is the answer to that, and that is how you can apply integration on parts to find the integral of the product of two given functions. So thank you, and God bless you. So I just hope my mic